Welcome to the basic U-Sub lesson. One of the techniques to solving integrals is using U-Substitution. And usually these functions are within a chain. And theoretically speaking, you would use a chain rule if you were to differentiate. So in this first example, we can sub in u for x to the third plus 1. And the next step would be to get to du. du is going to be, we're now going to find the derivative of this function. So 3x squared, we have to add a dx. So then we have to know what dx is equal to, so we can re-evaluate using something that's not just dx. So this would be du over 3x squared. And look how nice, we were able to cancel out 3x squared. So if we go back inside this integral and we multiply with du, but we have to put in u, right? We have to put in u. So du over 3x squared. Look at that. As we've stated before, those cancel, and we're left with the integral as u to the fourth du. And now all we have to do is do the antiderivative. So u to the fifth over 5 plus c, since it's not a definite integral, it's indefinite. So now we just need to put u as in terms of x. So x to the third plus 1. And we can also get the 5 outside, so 1/5 parenthesis and then plus c. So that'd be the answer to the first one. The second one is going to be the same idea. You can kind of tell that you could use a chain in that instance, and so that's when you have to use U-Sub. So x squared plus 4 du is equal to 2x dx, and then just find dx. So du over 2x. And look how we can cancel. But in the first problem, we could cancel more. But in this case, we could only cancel the x's, which is also pretty neat. But not all the time we're able to cancel values of U-Sub. That's not the intended purpose. There's much more than just canceling. You can also move things outside of the integration symbol. So 5x, we will sub in u for this expression, and then du over 2x. We can divide out an x, so those are canceling. So one of the neat things about the integral is that 5 over 2 can move outside, and so we're left with u to the third du. And now I can use the antiderivative. And the antiderivative is plus 1 divided by the new exponent. So in this case, it would be 5 over 2 u to the fourth, right? You're adding 1 from the exponent, divided by 4 plus c. And again, this would be the constant for integration.